My name is Bobby Sethi. I'm a senior lecturer in gas turbine combustion and environmental impact at Cranfield University and I'm the coordinator of the EnableH2 project. Liquid hydrogen has the potential to completely decarbonize civil aviation. At the moment, this is a minority view within the industry, mainly due to the much higher cost associated with the infrastructure required. But as soon as conventional fuel prices, emission taxation scenarios, and the sheer necessity of transformation are taken into account, the cost of transition is going to look remarkably modest for such a fundamental long-term solution. Flightpath 2050 very ambitiously targets 75% CO2 and 90% NOx emissions reductions relative to the year 2000. It will be extremely challenging to meet these targets with carbon-containing fuels, despite large research efforts on advanced disruptive airframe and propulsion technologies, even when coupled with improved asset and lifecycle management procedures. Even if we were able to meet these targets, this would not be sufficient in the longer term for a fully sustainable future for civil aviation, particularly considering the rate at which other sectors plan to decarbonize. EnableH2 is an acronym for Enabling Cryogenic Hydrogen-Based CO2-Free Air Transport, an approximately €4 million project funded by the EU Horizon 2020 program. Cranfield University are the coordinators of the project, and other project partners include Safran, GKN, the European Hydrogen Association, Heathrow Airport, Chalmers University, London South Bank University, and Arctic. We have also established a highly active, dedicated industry advisory board comprising several key civil aviation stakeholders. The project aims to revitalize enthusiasm in LH2 research for civil aviation by maturing key enabling technologies and through addressing key challenges and skepticism associated with its introduction through a combination of both numerical and experimental research and innovation. The key technologies being matured are hydrogen micromix combustion for ultra-low NOx emissions and the fuel system heat management to utilize the formidable heat sink potential of LH2 as an enabler of disruptive propulsion technologies. There is also a dedicated work package related to delivering best practice safety guidelines for LH2 at aircraft, airport, flight, and operational level. The EnableH2 technologies will be evaluated and analyzed for more conventional and maximum synergy advanced aircraft configurations. The technology evaluation work package will assess energy efficiency, emissions, life cycle CO2, and life cycle costs for a range of potential fuel price and emission taxation scenarios. The benefits of LH2 will be quantified relative to best case scenario projections for Jet A, biofuels, and natural gas. We look forward to meeting you at the ICAO event in September, where we will provide you with an overview of the key achievements to date, as well as 12 key technology research strands that we have identified for the introduction of LH2 for civil aviation as part of our preliminary road mapping exercise. Thank you.